Welcome back, Focus Learners, to another Explainer. Today, we're unpacking a topic that is fundamentally reshaping the world as we know it. I want you to imagine a machine that never, ever needs to sleep. A system that never forgets a single piece of information it's ever learned. And unlike us humans, it can study millions of pieces of data in the time it takes you to blink, literally. This isn't the plot of some sci-fi movie anymore. It's the reality of artificial intelligence right now. In recent years, the US has become an absolute epicenter for this global AI revolution, with labs building systems that can write, reason, and create at just astonishing speeds.
So with all this rapid advancement coming out of Silicon Valley and top-tier labs around the world, we really have to pause and look at the big picture. How far can artificial intelligence actually go? And perhaps the most profound question we face today, are we actually prepared for what comes next?
Okay, let's dive into this. The stakes for our explainer today really come down to a pretty stark biological reality. We humans are brilliant, sure, but we're bound by biology. We need sleep, and absorbing complex new information, well, that takes years of dedicated study. AI, on the other hand, operates on silicon. These systems can analyze millions of examples instantly, and the retention is absolutely perfect. Understanding this massive gap in data processing capability is exactly why this technological leap is unlike anything we've ever seen in human history.
To really understand where we're going, we need to quickly look back at how we got here. Part 1. The dawn of AI, a brief history.
The concept of artificial intelligence is actually way older than you might think. Back in the 20th century, scientists began asking a very simple but super ambitious question: could a machine be designed to mimic human intelligence? Now, for decades, progress was painfully slow. Early computers were incredibly great at calculating massive numbers really quickly, but they completely failed at simple tasks like recognizing a picture of a cat or understanding basic spoken language. But then we hit the modern era. Two huge shifts happened at the exact same time. Computers became dramatically more powerful, and we suddenly had an absolute explosion of digital information available to feed them. That explosion of massive data and computing power led directly to a major paradigm shift in how we actually build these systems. Part 2, Machine Learning, the Revolution.
So instead of software engineers sitting down and manually writing out every single individual instruction, which, by the way, is how traditional programming worked for decades, researchers came up with a completely new approach. First, you input enormous amounts of data. Second, instead of being told what to do, the machine hunts for patterns in that data entirely on its own. It's kind of like showing a system 10,000 photos of bicycles until it independently figures out what makes a bicycle a bicycle. And third, the system learns without explicit programming. It discovers patterns that might not even be obvious to the human eye.
Now, what's really interesting about this is how widely it's already being applied across the country. This isn't just confined to big tech headquarters anymore. Right now, AI-assisted systems are helping doctors spot tiny anomalies in X-rays that the human eye might naturally miss. Scientists are using it to unravel complex biology. Engineers are out there building self-driving cars, and everyday businesses are automating those boring, repetitive tasks. Even ordinary people are interacting with AI daily, often without even realizing how deeply it's already woven into our lives.
But you know, the most fascinating developments are happening deep inside laboratories, completely away from the public eye. Part 3, Scientific Partner, AI in the lab.
Let's put this into perspective to see how it actually works in practice. Imagine a researcher trying to discover a breakthrough medication or maybe a new material for solar panels. Traditionally, they'd sit at a lab bench, manually testing chemical combinations for years. It's slow, methodical work. But with AI, computational models can instantly search through vast, practically infinite possibilities and predict the most promising candidates right away. It essentially turns a 5-year guessing game into a 5-minute targeted roadmap. No way, right? But it's true.
Now, I want to be very clear about what this actually means. AI does not replace the scientists. Actually, scratch that. It's more like it supercharges them. The brilliant human researchers are still firmly in the driver's seat. What changes is the velocity. By acting as a partner, AI gives human researchers a digital Iron Man suit, allowing them to explore vast possibilities at a pace that was completely unimaginable just a decade ago. It changes the entire speed of human discovery.
However, with all this incredible speed and raw capability, the questions we have to answer become infinitely more complicated. Part 4, The Trust Problem, Complicated Questions.
I want to pause here for a second and let you really think about this. Can we always trust an AI system? Because as these complex models start making critical decisions about our healthcare, our finances, and our infrastructure, this is the hurdle we absolutely have to face head-on.
There are three major, highly practical debates currently raging among scientists, businesses, and governments right now. First, hallucinations. What happens when an AI produces information that sounds incredibly confident but is entirely made up? It's a massive reliability issue. Then there's liability. If a doctor relies on an AI diagnosis and it turns out to be wrong, who actually gets sued? The software developer or the hospital? And finally, job displacement. We're looking at machines capable of performing complex tasks we once thought only highly trained, educated humans could do. These aren't futuristic sci-fi concepts. These are very real debates happening right now, and finding the right balance is absolutely crucial.
Moving beyond our current debates, what does the next stage actually look like? Part 5. The future of AI, what comes next?
Well, the next stage isn't just going to be text-based chatbots on your web browser. We are moving toward highly capable autonomous agents. Future systems will seamlessly see, hear, and reason about the physical world around them. They'll independently use digital tools, operate physical robots, and execute highly complex, multi-step tasks while you sleep, with significantly less human supervision than they require today.
And this brilliantly illustrates how this looks in practice. You could give an AI a simple prompt. Study this scientific problem and find possible solutions. Instead of just spitting back a Wikipedia summary, a future AI could independently scour the entire history of scientific literature, create its own data simulations, compare all the outcomes, and present you with a fully realized research plan. It literally graduates from a simple digital tool to an independent digital employee.
So, the crucial point is, there is a catch. The more independent these systems become, the more vital human oversight becomes. It's a really delicate balancing act. Autonomy in AI is a powerful engine for progress, for sure, but human oversight is the steering wheel required to ensure that progress remains safe and actually aligned with our goals.
If we get that balance right, though, AI's ultimate potential is just staggering. We are talking about technology that could massively accelerate the cure for diseases, help us unravel the deepest mysteries of the universe, and discover entirely new sustainable materials. It literally holds the key to solving generational problems that humanity has struggled with for centuries.
Which leaves us with this final thought. Technology itself doesn't decide how it gets used, people do. The biggest scientific story of the coming decades isn't some dystopian tale of machines replacing us. It's about what happens when human intelligence and artificial intelligence truly begin working together. The story has only just begun. The question is, how will we choose to write the next chapter? Thanks for joining me on this explainer, Focused Learners. Keep asking questions, and I'll see you in the next one.